Welcome to homework.
Okay, so the intensity can be equal to average power over area, which is equal to average power over 2 pi h squared. H is the height from the surface of Earth to the satellites, okay? And H can be equal to R minus capital R. Lowercase r here is the radius of the circular path of the satellites, and capital R here is the radius of Earth. So therefore, the time period for the satellite, which is T here, is equal to 2 pi squared times R to the power of the 3 over 2, and then over square root GME to the power of 2. Capital G here is the universal gravitational constant, and ME is the mass of the Earth. If we do some arrangement here, eventually we'll have R is equal to T squared times GME over 4 pi squared to the power of 1/3. We know the time period for the satellite should be half day, which is about 4.32 times 10 to the power 4 second. And the gravitational constant is 6.67 times 10 to the power negative 11 Newton times meter squared per kilogram squared. And we know mass of the Earth is 5.97 times 10 to the power 24 kilograms. And this will give us the radius of the circular path of the satellites is about 2.66 times 10 to the power 7 meter. So now we have the height from the surface of Earth to the satellites is equal to R minus capital R, which is equal to 2.022 times 10 to the power 7 meter. Okay, and the capital R here, which is the radius of the Earth, is about 6.38 times 10 to the power 6 meter. So now let's determine the intensity. And we know the average power should be equal to 25 watts, which is equal to 50 watts over 2. Okay, so now if we plug in back to the equation, we'll have I is equal to 25 watts over 2 pi n times h squared, which is 2.022 times 10 to the power of 7 meter to the power of 2. And this can give us the intensity is about 9.73 times 10 to the power of negative 15 watts per meter square. So this is the value for the average intensity. And for the next question, well, we know the amplitude of the magnetic field, which is Bmax here, is equal to maximum electric field over speed of light. And we know the intensity can be equal to 1/2 epsilon 0 times C and then times Emax squared, which will give us Emax is equal to square root 2I over epsilon 0 C. We know I is the average intensity, and epsilon 0 is the permittivity of the free space. Okay, and we know C is speed of light. Okay, so we know the value for the intensity is 9.73 times 10 to the power negative 5 watts per meter squared. And we know epsilon 0 is 8.85 times 10 to the power negative 12 coulomb squared per Newton times meter squared. And we know speed of light is 3 times 10 to the power 8 meter per second. So therefore, let's determine the amplitude of the electric field, which is equal to 2.71 times 10 to the power negative 6 Newton per coulomb after the calculation. Okay. So now we can determine the maximum magnetic field, which is equal to Emax over C. If we plug in the values, we have 2.71 times 10 to the power negative 6 Newton per coulomb over 3 times 10 to the power 8 meter per second. And this will give us the amplitude of the magnetic field is about 9.03 times 10 to the power negative 15 Tesla. So now let's determine the time. The time is equal to the height from the surface of Earth to the satellites over the speed of light, which is equal to 2.022 times 10 to the power of 7 meter over 3.0 times 10 to the power of 8 meter per second. And this will give us the time is about 0.0674 second. Okay, so you take the signal to reach the receiver by about 0.0674 second. For the next question, the P prime here is the average pressure, and I is the intensity, C is the speed of light. So when the P prime can be equal to I over C, which is equal to 9.73 times 10 to the power of negative 15 watts per meter square over 3.0 times 10 to the power 8 meter per second. And this will give us the average pressure is about 3.24 times 10 to the power of negative 23 Pascal. So this is the value for the average pressure. And for the last question, well, we know wavelength is equal to speed of light over the frequency. We know frequency is given as 1,575.42 megahertz, which is about 1,575.42 times 10 to the power 6 hertz. So therefore, the wavelength can be equal to 3.0 times 10 to the power 8 meter per second, and then over 1,575.42, and then times 10 to the power 6 hertz. This will give us the wavelength is about 0.190 meter. And these are the answers for this question.